Assalamu alaikum students, welcome to our channel Study Time. Today we are going to discuss a very important topic, that is stationary waves. Here I will discuss the definition and the types and some important points of stationary waves. I will explain all the factors and points of it. Now let's move towards the definition of stationary waves. What are stationary waves? Stationary waves are two waves that have same frequency, travel in opposite direction, and superpose each other. How? I will explain you with the help of a diagram. Now let's draw a wave here. This is one wave and this is the second wave that is in the opposite direction. You can see that both these waves are in opposite direction and both have same frequency equal to 1. One wave has one frequency. Okay, now the another point in the definition was that these waves superpose each other. As we have seen that they have same frequency as the one wave, it means frequency will also be equal to 1, and both these waves are in opposite direction also. So now these will superpose each other. It means that they will add up. How? Let's see. Let's draw the diagram again, and I will combine both these waves together. It means they will add up. This is how. One in this direction and the other in the next direction, and both these waves are combined to each other. Stationary waves literally means standing waves. It means the wave is not moving. Both these waves have same frequency and are traveling in opposite direction, one this way and one the other way, the green line, and are adding up. Okay, I hope you will have understood the definition of stationary waves. Now let's move toward the types, the points present on the stationary waves. Now the first point here is node. What is node? The points on the stationary wave that show zero displacement, and it is represented by n, the alphabet n. Now let me explain you with the help of a diagram. Now the points that you can see, the purple points, are the nodes here and are represented by the alphabet n. This is n over here, this part is n, this is n, and this one is n. You can see there are 4 nodes present over here, and they have zero displacement, as there is no distance present between this one, no distance between present this one, and no distance between both these one. That is why we call that nodes have zero displacement. Now let's move toward the next point, that is antinode. The points on the stationary wave that show maximum displacement and are represented by A, the alphabet A. Now how they show maximum displacement? As nodes show zero displacement, these are opposite to it. They show maximum displacement. Let's see it with the help of a diagram. Again with this diagram, you can see the blue points here are the antinodes, and they have a displacement. They cover some displacement from the start point towards this end point. They cover some displacement. That is why we call that antinodes have maximum displacement. Okay, this part is the antinode. From this to this is the antinodes, and we represent it by A, the alphabet A. We have 4 nodes in this diagram and 3 antinodes. It means that the number of nodes present, there is 1 less antinode. 4 nodes present, it means 3 antinodes are present over here. Now let's move towards some important points. The first point is the distance between 2 consecutive node and antinode, that is lambda by 4. How? Now this is node and this point is the antinode. This point is also antinode over here, and there are 3 nodes here in this diagram. It means the distance from this node to the antinode is lambda by 4. This distance is lambda by 4. Again, if we see this distance from node to the another antinode, it is lambda by 4. Okay. The next point, the distance between two consecutive nodes is lambda by 2. Now let's see this with the help of a diagram. Now these are two nodes present over here and two antinodes from this point to this point. Now the distance from one node to the another node is lambda by 2. And the distance from one antinode to another antinode is lambda by 2. As we saw in the first point, that the distance from one node to another antinode is lambda by 4. It means the distance between two nodes will be lambda by 2 if we double these amount. How can we double it? The length, that is lambda by 4 from one node to antinode, and from another node to antinode is lambda by 4. Now when we take the LCM, we get is 2 lambda over here, and we solve this, we get is lambda by 2. It means the distance from one node to another node is lambda by 2, and the distance from one antinode to another antinode is lambda by 2. Okay, this was the two important points of stationary waves that you should know for MCQs, and also for the key points that you should also write in the definition. Now I hope you will like our lecture. Do subscribe our channel and click on the notification button to get updated for more videos. Thanks for watching our video.